This video will cover the Geometry Regents exam from January 2015, questions 11 through 15. Number 11 says a circle whose center has coordinates -3, 4 passes through the origin. What is the equation of the circle? In order to write the equation of the circle or choose our answer here, we have to understand that the equation of a circle is written as x minus h squared plus y minus k squared equals radius squared, r squared. And that h comma k, the h and k together, make up the center. So as you'll see, we need negative h and negative k, so the opposite of the center gets plugged into the equation, which means that this -3 now becomes a +3, knocking off choices 3 and 4. The next step is to figure out what the radius is, and in order to do that, we need to figure out the distance between the center and a point that it passes through. So here I can find the radius by using the same method we did to find length, because all we're doing is finding length here. Change x, change y, Pythagorean theorem. So here I have passing through the origin, meaning that we pass through the point 0, 0. If you want to take a second to sketch this, you certainly can. We're at -3, +4, and 0, 0. The center of the circle is here, the outside of the circle is here, so unfortunately mine would run off the paper. But the radius, again, is just the length between the center and that point, the origin, 0, 0. So change, remember, means to subtract. So we have -3 minus 0, and 4 minus 0. -3 minus 0 is -3. 4 minus 0 is +4. But remember, when we're plugging into the Pythagorean theorem, we don't care about negatives because negatives squared become positive. So we have 3 squared plus 4 squared equals c squared. Sum those two and you get 25 equals c squared. Square root both sides, and you get 5, meaning the radius is 5. But remember that the equation says we need r squared. So r squared is 5 squared, which puts us back at 25. So what we could have done in this problem was stop at 25 equals c squared. Or in other words, r squared, because the radius needs to be squared to write the equation, giving us choice 2 as our final answer. Number 12 says point W is located in plane R. So I'm going to sketch this as we draw here. Point W is located in plane R. How many distinct lines passing through point W are perpendicular to plane R? So here it's important to understand that perpendicular lines form right angles and are intersecting in opposite directions, essentially. So if I think about this plane as a piece of paper lying flat on, say, a table, and this point is just a dot on the paper, I want to draw a line that's perpendicular through that dot, passing through the paper. So in other words, if the paper's flat on the table, then my line has to go vertically. So if I try sketching a line through point W through plane R, I know that I can definitely get at least one line that's perpendicular. If I try to sketch another, say, again, the paper's lying flat on the table, and I sketch another going in this direction, this line that I just drew is not perpendicular, does not make a right angle. And if I try doing this in any other direction, I don't get perpendicular lines. So the answer here is choice 1, with the word 1. And this is actually a case that you can always think of when you see the words point, plane, perpendicular. The answer every single time is the number 1. Point, plane, perpendicular, 1. Number 13 says, in the diagram below, line L is parallel to line M, and line W is a transversal. All that means is that it's passing through the two lines L and M. If the measure of angle 2 is 3x plus 17, and the measure of angle 3 is 5x minus 21, what is the measure of angle 1? Now I can't just call this x because x is already being used. However, I can say that angle 1 is the same measure as angle 2, 3x plus 17. I'm going to write measure of angle 1 equals measure of angle 2, and this is because they are corresponding angles, which are congruent when lines are parallel. So in the end, I'm going to be able to solve for x and plug back into the same expression as I have in measure of angle 2. In order to solve for x, I need to use the two given angles, 2 and 3. Angle 2, the measure of angle 2, plus the measure of angle 3 is equal to 180 degrees because they're on a straight line. They are supplementary. So now we have 5x minus 21 plus 3x plus 17 equals 180. Combine like terms and solve. Pause the video, check back in with me once you've done this. So we find that x is equal to 23, but remember this is not our final answer. We need the measure of angle 1. And we said that 1 is congruent to 2 because corresponding angles are congruent. So we have 3 times 23 plus 17. So that's 69 plus 17 to give us a total value of 86 degrees for the measure of angle 1. Choice 4. So answers for this page here, we have number 11 is 2, number 12 is 1, number 13 is 4. Number 14, we have another circle problem. It says the diagram below is a graph of circle O. So O is the center. Which equation represents circle O? So again, equations of a circle are written as x minus h, parentheses squared, plus y minus k, parentheses squared, equals radius squared. H comma k is the center, and r is the radius. H and k are the center. So first I need to find the coordinates of center O. So it looks like I'm just going to count some boxes over 1, 2, 3, 4, 5. So we have 5, comma, 1, 2, 3, negative 3. And the radius, if we just count from the center to the outside, we have 1, 2, 3, 4. So r equals 4. So first I'm going to start by writing the equation x minus, and I'm going to plug in h, which is 5, parentheses squared, plus y minus k, which is negative 3, parentheses squared, equals 4 squared, radius squared. But remember, as I mentioned before, the signs switch when you plug in. This positive 5 now becomes negative 5. And you'll see here that that negative 3 will actually turn into a positive 3 because we have negative negative take away another negative. So final answer, we have x minus 5 squared plus y plus 3 squared equals 4 squared, which is 16, which gives us choice 3. Number 15 says an isosceles trapezoid QRST shown below, QR and TS are bases, which means that these two are parallel to one another. Because it's isosceles, QT is congruent to SR. There are two congruent sides, which also means that angle Q is congruent to angle R, and angle T is congruent to angle S. Isosceles trapezoids work in very similar fashion to isosceles triangles, where there are two congruent sides, and the base angles are congruent. Because we have two bases, we have two pairs of base angles. So here it says that the measure of angle Q is 5x plus 3, and the measure of angle R is 7x minus 15. Again, we just mentioned that angles Q and R, those base angles, are congruent because it's isosceles. So here I'm going to set them equal. 5x plus 3 equals 7x minus 15. Go ahead to take a second and solve, and then remember that you are asked for the measure of angle Q, so go ahead and plug back in to find your final answer. Pause the video while you do this, and then check back in with me. So here I found my final answer to be choice 2 after plugging the value of 9 in for x in the expression 5x plus 3. Final answers for this page are number 14 is 3, Number 15 is 2.